Everyone. Myself Malaika Chahar and my department is BS Chemistry. Today I will be discussing a crucial material elevation process in the glass industry, the acid resistance test, a method used to assess how durable a glass is when exposed to acidic environment. Glass is widely used from the laboratory tools to food containers, and not all the glass is equally resistant to chemical attack. This step helps us to ensure that glass we use daily can withstand harsh conditions without degrading or leaching harmful substances. Let's dive into the chemical history behind this test, the procedure, and its industrial significance. Chemical foundations of glass durability. To understand why this test is important, let's first talk about the chemical structure of glass. Most commercial glass is based on silicon dioxide, SiO2. It also contains other metal oxides like sodium oxide, calcium oxide, and boron oxide. When acids like hydrochloric acid or sulfuric acid come into contact with glass, this added oxide can react and leach out as ions. For example, a typical reaction is Na2O, for example glass, plus 2HCl forms 2NaCl plus water. This means sodium ions leave the glass and enter the solution. However, SiO2, the backbone of the glass, is much more stable and resists this attack. Why is this important? If ions like Na plus, Ca2 plus, B3 plus leach out, they can weaken the glass and contaminate substances stored in it. That's a major concern for industries like pharmaceutical and food packaging. Objectives and interpretations of results. So, what does this test really aims to do? The main goal to measure how well glass can resist acid corrosion. It tells us whether the glass is chemically stable, how much material it lost during the exposure, and how many ions leached into the solution. The more weight or ions lost, the less durable the glass is. This is critical because compromised glass could lead to contamination of medicines, breakdown of lab equipments, or leaching of toxic into food or drinks. Material required for testing. To perform the acid resistance test, we need glass sample cut to standard size, 1 NaCl or H2SO4 as a acid medium, beaker and filter paper, distilled water for reasoning, an oven for drying sample, and analytical weight for accurate weighting. Each sample or materials plays an important role in ensuring the results are accurate and reproducible. Step by step its procedure. The first step is sample preparation. First step of this cut them to uniform sizes to ensure equal surface area. Wash them to remove the dirt or oils. Dry the sample in an oven at 105 degrees Celsius to remove all the moisture. Then cool them in an accelerator so they don't reabsorb water from the air. Finally, weight them using a sensitive analytical balance. This gives us a baseline weight, very important for calculating how much material is lost after the acid exposure. Then the quantitative analysis. There are two main ways to quantify the acid resistance. Weight loss formula. Use the formula weight loss mg over dm square is equal to initial weight minus final weight over surface area. This standardizes the data so samples of different sizes can be fairly compromised and compared. ion leaching analysis. You can also test the acid solution to see which ions leached out using titration spectroscopy method like AAS, atomic absorption spectroscopy. Post-treatment cleaning and drying. After exposure, remove the glass pieces carefully, wash them thoroughly with distilled water and remove the leftover acid. Dry them again at 105 degrees Celsius and cool to reweight them. Now compare the before and after weights and then tell us how much material was lost during the acid attacks. And then thus the acid exposure, explode the sample to acid, immerse them in 100 ml of 1N HCl or H2SO4, heat the solution to about 95 degrees Celsius near boiling and maintain them 3 to 6 hours. Why high temperature? Because it accelerates the reaction, stimulated the long-term exposure in a shorter time. This step is where the ion exchange and leach out happens. This method is more detailed. For example, if you use the high concentration of Na+, it means the glass has poor resistance to acid attack. And now explain the applications across the industries. This test has a wide application in critical industries. For example, in pharmaceutical industries, ensures that viral and apocalypse don't contaminate the drugs. Food and beverage. Test if bottles or jars can safely hold the acidic drinks like soda or juices. Laboratory glasswares. Confirm that beakers and flasks can handle strong chemicals without breaking down. In all these cases, acid resistance ensures the safety, purity, and durability. Future directions and innovations or future outlooks. Looking ahead, scientists and manufacturers are finding ways to enhance the acid resistance in glass. First of all, advanced coatings. Apply transparent acid resistance layer that does not interfere with clarity or strength. Second one, smart sensors. Embedded mini sensors in a glass containers to detect the degradations in real time. Third is predictive modeling, using AI stimulation to design the better glass recipes without physical testing. Sustainable protocols. Reduce use of harsh acids in testing and minimize the environmental impact. Global harmonization follows international standards like ISO 695 to unify the testing methods globally. All of these steps aims to create the stronger, safer, greener glass products. In conclusion, the acid resistance test is critical and quality control method. It helps us to understand how glass will behave in real world conditions, especially when exposed to acids. By knowing how to conduct the test, interpret results, and apply them in industries, we can ensure better safety, longer product life, and more sustainable manufacturing. Thank you for your attention.